in memoriam of Professor Albert Eschenmoser, that died in July 2023. Professor Eschenmoser was of Swiss nationality, and he did all his studies and faculty career in the ETH, Zurich, where he performed undergraduate studies and graduate studies, and then he was faculty until he completely retired. He got a PhD in organic chemistry in 1951 under the supervision of Nobel Prize winner Leopold Ružička. His areas of research dealt with organic and bioorganic chemistry, and he's considered to be one of the giants of these fields in the 20th century. In 1955, he made one of the breakthrough discoveries, together with Nobel Prize winner Ružička, on reaction mechanisms and stereochemistry of terpenoids. He provided the mechanistic foundation to explain the so-known isoprene rule. Isoprene are 5 carbon units that then constitute terpenes and terpenoids, which are 10 carbon units and more, with a rule that increases the length of the chain by 5 carbons each time. And this family of compounds, the terpenoids, constitute the largest family of natural products existing, with about 30,000 or more molecules in nature. These are of hydrophobic characteristics, and just to say some of the terpenoids that are important for life, both plants and mammalian biology, animal biology, we can talk about carotenoids, ubiquinone, which are electron transport carriers, and even the esteroids are form of precursors, terpenoid precursors. Then he started to shift from organic chemistry to bioorganic chemistry. There is a nice shift in his trajectory. And another breakthrough was done in collaboration, as per his words, a 12-year competitive collaboration with Professor Woodward from Harvard. And at the end of this 12 years of work, in 1977, they published a paper in Science where they communicated the total synthesis of vitamin B12, which was at the time the most complex biomolecule to be synthesized so far in history. So that was a major breakthrough, and there were many tips to finalize the Corin ring, which was the major challenge of the synthetic pathway. Then he continued shifting to getting closer to biology, and in 1999, Professor Eschenmoser published a breakthrough paper in Science also named The Chemical Etiology of Nucleic Acid Structure, where he defined that the pentose ring, meaning the ribose and the oxyribose rings on the nucleic acids, are the main structural factors causing the double helix, in spite of the original thought that the base pairing was the most critical aspect. So that was a major breakthrough. He was a member of many, many international scientific societies, including member of this academy. In exchange with Professor Von Braun, he documented to me that his last meeting here live was in 2009. He was also a member of the National Academy of Sciences of the US, the European Academy, Leopoldina, etc. His work profoundly influenced organic and bioorganic chemistry. And just to take a few editorials from Science right after he passed away, some of his previous students say that he was known and appreciated by the words of their students and faculty members: originality, intellectual rigor, experimental ingenuity, warm-heartedness, and sense of humor. Thank you.